Welcome to this football instructional tackling video. First off, congratulations on joining the Milton High School football team. Let's get started now. This is Chris.
I'm ready to hit some people.
This is Aiden.
Raggle fraggle.
Today, Chris will be tackling Aiden today. Let's begin.
Hi,
Hi,
my name is Dr. Jang.
and I'm Dr. Ruteki.
We are here today to teach you about physics.
Specifically, the conservation of momentum.
We have a special guest today, Mr.
Ron Burgundy.
Ron Burgundy. And we're going to teach Ron Burgundy about physics. Let's get to this. Here you see our first test subject, Chris. And over here you see our second test subject, Aiden. Now I know you're all wondering what these crazy letters and numbers mean. Well, Andy here is going to tell you what they mean.
M stands for mass. It's how much stuff is inside of you. V stands for velocity. It is the speed and direction of an object. Now P does not stand for a letter or word that begins with P, but stands for momentum.
I bet you didn't get that.
If we come to this equation over here, we find that momentum is gotten by multiplying the mass and velocity of an object. Dr. Jang, would you like to explain?
Yes, sir. Now, we've measured the mass of Chris, which is 52.7 kilograms. His velocity is 9.5 meters per second. And you are wondering how you get momentum. Well, you just multiply mass and velocity, and you get the momentum of 500.65 kilogram meters per second.
Big number for a little guy.
Yes, indeed. Now, for Aiden, his mass is 100 kilograms.
Fatty.
His velocity is -2 meters per second. Now, I know you're wondering why it's negative. It's negative because in this test experiment, our test subject Aiden is running in the opposite direction of Chris. That is why his velocity is negative. And now, using the formula over there, mass times velocity, and you get the momentum of -200 kilogram meters per second. Now, you are wondering what this here is. Andy, would you like to explain?
Well, first off, you're going to need to know what this is. I know they look like two random arrows, but really, it's an organizational tool that we use to simplify problems like this.
Don't worry, I got this. It's used to show what direction the arrows are going.
I'm going to ask you to get out of the way. Thank you. That's very intelligent of you. That's correct. It shows the direction of the momentum using the arrowheads. Now, I'm sure what you're wondering these little A's below the P's mean. A's and C's. Well, A stands for Aiden, and C stands for Chris. This is the momentum of Chris and the momentum of Aiden. So then, What does T mean? T stands for the total. So you can see that the total momentum is equal to the momentum of Chris plus the momentum of Aiden. So when we plug in values such as 500.65 and negative 200, we get that the total momentum of the two combined is 300.65 kilogram meters per second. But that's simply before they collide. Using the concept of conservation of momentum, we will find out the unknown, which in this case is the velocity of Aiden after the collision. Conservation of momentum is the notion that the total momentum does not change, and that only its inputs do. So, Dr. Jang, would you like to explain what the tallies mean?
As you see here, the momentum of Chris has stopped to a point because after the collision, so hard he hit Aiden that he just stopped and the momentum of Aiden just fell back in a hard recoil. Now, this here formula means that the total momentum prime equals total momentum. And here we are trying to find the total momentum prime, which means the momentum after the collision. And using our previous specs, we take the total momentum prime equals the total momentum of Chris prime and the momentum of Aiden prime. So in the previous, the total momentum is 300.65 kilogram meters per second, and we take Chris's mass times 0 because his velocity is 0, and we take Aiden's mass, which is 100, but we have to find out what velocity is. What is velocity of Aiden after the collision? Well, you have to divide by 100. Now you see here, 300.65 equals 100 V. You divide by 100. The final velocity of Aiden after the collision is 3.0065 meters per second. Such a hard hit. I hope he's doing okay. I hope he's doing okay in the hospital.
I believe he's dead now.
Oh, I've spoken too soon.
So today we're going to be solving the momentum of Aiden using trigonometry. Now, as you can see here, the momentum of Chris and the momentum of Aiden collide at an angle of 60 degrees, which is represented in this here triangle. Now, right here, you see the momentum of Chris, which is 158.1 kilogram meters per second. And right here, L represents the momentum of Aiden. And right here, H, the hypotenuse, represents the total momentum of a collision. So to find these two variables, we need to use trigonometry, and in this case, cosine of 60 equals 158.1 over h. Now, according to the rules of mathematics, we switch h and cosine of 60, and you do the math, and we get 316.2 kilogram meters per second. Now, to find the leg, or Aiden's momentum, you use the tangent of 60. You get the leg over 158.1. And then you multiply by both sides to get L by itself. And when you multiply on this side, you get 273.84 kilogram meters per second. Now, coming over here, to find the final velocity, you do 273.84 kilogram meters per second set it equal to mass times velocity, which is 100 times v. Now when you divide by 100, you get 2.7384 meters per second, and that is the final velocity of Aiden.